How do you find the value of this complex inverse trigonometric expression? Notice that we're talking about inverse because there's a arc sine here expression of 1/3, and there's a arc cosine expression of 2/3. Right? So what this basically means is that you're trying to find the sine of the sums of two inverse values, right? This means the angle whose sine is 1/3. This means angle whose cosine is 2/3. So the first thing I would do, I would let A be equal to arc sine of 1/3. Okay, that's the first substitution. Which means that if that is true, then the sine of A as a result, you're going to take the sine of both sides, which is equal to sine of this side, like that, is going to be itself, the input, the original input, right? So that's going to be 1/3, okay? And this is only true when 0 is less than A is less than pi over 2, okay? Because we know A has to be somewhere between 0 and pi over 2 in order for sine of A to be equal to 1/3, right? We know sine of 0 is 0. We know sine of pi over 2 is 1. So 1/3 is between 0 and 1, okay? So we know that for sure. So that means we can use another substitution now. Let B be equal to the arc cosine of 2/3. Now in that case, we will take the cosine of both sides, cosine of B on the left side, and cosine of the arc cosine of 2/3. Cosine of the arc cosine of 2/3. And we know this is equal to essentially 2/3, the input of the inverse function for the cosine. And that is only true when 0 is less than B is less than pi over 2, right? Because we know we're talking about the first quadrant, right, of the unit circle, because both sines and cosines are positive, right? The cosine is going to be 2/3, okay? So it must be between 0 and pi over 2 because in general the inverse is defined only when the cosine function is between 0 and pi, right? In this case the cosine is positive, thus the pi over 2 is going to be the constraint, starting from 0 all the way to pi over 2. So we're not going to go to the second quadrant, even though theoretically the cosine can take 1 and 2 quadrants, right? The first quadrant and the second quadrant in order to have an inverse. In this case, only up to pi over 2 because the cosine is positive. So now that we have that, we can actually we can rewrite the original expression as sine of A plus B. Now you know this will equal to, based on one of the previous videos in which I talked about the angle addition formula, angle sum formula, it's going to be equal to sine of A cosine of B plus cosine of A sine of B. And what I can do, I can show you this with colors so that you can see once again. Be sure to review that video in which I talked about this formula. Okay. So as you can see, these are different cosines. This is going to be a different cosine than this one because the angles are different, right? A and B are different angles. And so is the same for the sines, right? Sine of B versus sine of A. Be sure you see that. So as a result, now we know the value of sine of A, right? We know sine of A is there, and that's equal to 1/3. So we can go ahead and actually substitute that in. And the cosine of B we also know, that's equal to 2/3 according to the substitution. Now what we don't know is the cosine of A and sine of B, right? In order to do that, we're going to use a right triangle for each of these two cases. So for the cosine, notice that we can write the angle A here. We're going to use sine first of all, right? We know the sine of A is equal to 1/3. So sine of A is opposite over hypotenuse, right? We know that based on sine of A being equal to 1/3. We know that A is the angle, if you let A be the angle, which it should be, the opposite over the hypotenuse is precisely the sine of A. That means we can find the cosine of A using the third unknown side. Notice that using the Pythagorean theorem, you can solve this as 3 squared minus 1 squared under the square root, right? And that would be equal to 9 minus 1, radical 8. And further, that could be equal to 2 radical 2, right? Because 4 times 2 inside, take the 4 out, square root of 4 is 2, so you take it out, 2 radical 2 is what you get. So now this is the value of the cosine of A, thus will be 2 radical 2 divided by 3, right? So 2 radical 2 divided by 3. Now for the second triangle, we're going to need to find the sine of B. We know the cosine of B, which is equal to 2/3, right? So if we let this angle be B now, we know that cosine of B is 2/3, right? So cosine of B is adjacent, which is this side, over the hypotenuse, right? The longest side opposite to the 90-degree angle, to the right angle. So that means we can find the missing one in order to find the sine, right? The opposite side. So that's going to be what? That's going to be using the Pythagorean. This is going to be 3 squared, right? Hypotenuse squared minus the 2 squared, minus the second known side. And inside a square root, of course, right? Because the Pythagorean's a squared plus b squared is equal to c squared. To find any side, you will eventually have to take the square root, right? So that is equal to 9 minus 4, which is equal to radical 5. Okay, so as a result, the sine of b is going to be this opposite side divided by the hypotenuse. So radical 5 divided by 3. So what that gets us to is 2 over 9 plus 2. Now radical 2 times radical 5 is the same thing as 2 times 5 inside the radical, right? Over 9. So the final result will be what? The final result will be 2 plus 2 radical 10, the product, divided by 9. Okay, so this would be the evaluated expression based on the original complicated expression provided that had contained the inverse values as well. All right, so I hope this was useful. Thanks so much for watching, and see you in the next video.